unlocking value with Walrus LSTs. Today, we're going to dive into the process of staking and unstaking and why it's so different from Sui. Liquid staking protocols are the best way to enhance the user experience for native staking. They basically lower the opportunity cost, because when you native stake, you get an NFT, and you essentially get locked out of the DeFi ecosystem, and you lose a lot of APY from those incentives. Walrus uses delegated proof of stake for its consensus. It's something we are all very familiar with because it's similar to Sui's. In essence, for the non-technical people here, any holder of the wall coin can delegate their voting power to their favorite node, either be Mirai, Interest, Aftermath, and so on. And by doing that, they stake their coin, and it signals Walrus that that node should receive more data because they're trustworthy and they will act for the benefit of the wider network. By getting more data, they are also, of course, they receive more rewards. Delegated proof of stake also facilitates the voting process to define the write and storage cost on Walrus. That's just how much it costs to actually put data and keep the data on the system. But Walrus, if you try to stake natively, you see that it's a bit different than Sui's, right? On Sui, you can unstake anytime you want, and you don't really have to think about it. And if you try to stake and then unstake on Walrus, well, it doesn't work so well. And why is that? I will give a very simple example for you to understand. Imagine that you have a group of whales that have about maybe 10 million wall coins, and they decide on day one to stake on the Mirai node. That's all good. And on the second day, they unstake from Mirai and they put on Interest. That means that if data is allocated based on stake, the Walrus protocol will have to move perhaps terabytes of data every 24 hours. And that's very inefficient and very resource intensive. It doesn't matter how much innovations they can put on with red stuff, you would mitigate everything. For that reason, Walrus actually uses what's called a multi-stage epoch. Each epoch on Walrus lasts about 2 weeks, and they have 2 stages. The first stage you can think about as the first week. It's the voting stage. Is when users can stake to a specific node, and the nodes can vote for the write and storage cost. This is a bit confusing, so now we're going to walk through a staking process and then an unstaking process to really unpack it. So imagine that I want to receive rewards for epoch 2. I actually have to stake my wall coin on the first epoch, and it has to be on the stage 1, because this is the stage that I can see, okay, so the Interest Node Labs wants to charge X amount to store data and to write data, and this is going to be the commission rate. So in this stage, users can freely stake on a node, and they can freely unstake. This is because they're not eligible for rewards yet, and the network is just waiting for the voting to finish. Once it crosses from stage 1 to stage 2, that can be seen as the second week on the epoch, your coins actually get locked, because now everything is set in stone, the storage and write price, and all the stake is assigned. This is when Walrus starts migrating the data from node A to node B to reflect the new staking balances. Just a caveat, it doesn't really matter, but the rebalancing of data actually happens when the epoch finishes. The TLDR is that if you want to get rewards for the next epoch, you need to stake on the epoch prior and on the first week. Unstaking is somewhat similar, but it is a bit more complex. So if you want to receive your stake back from the node, you need to submit a withdrawal request the epoch before, and it needs to be on the first stage again. It needs to be during the voting stage, because Walrus needs to understand, okay, this user wants to remove some stake from the Interest node, so we should also remove some data for it. Once it moves to stage 2, you can no longer submit withdrawal requests. Once the epoch finishes, there is another point. You will only receive your wall coins if the node is not on the committee. If the node is on the current committee set, you will only receive your wall coin back once all the migration is done. And this is for security reasons. When you stake to a specific node, you have to be careful. So you have to pick one that will benefit the whole network, right? It's because you are sharing the rewards and the penalties with the specific node. The nodes are paid. If they're actually holding the data, they are paid to do so. if they pass the storage proofs. And if they don't, they're penalized. And this is done via slashing. You actually may receive less wall coin than you stake if you stake to a node that doesn't behave honestly to the network. It is a self-custody process. That means that you are always in custody of your wall coin. What Walrus does is that he wraps your Walrus coin on an NFT, and you get this NFT back. This actually is a nice design. It goes with the ownership model of Sui, but it causes a big problem for Walrus because if you are holding the Walrus coin, what happens if your node is penalized and slashed? Walrus cannot just stake the coins back to cancel your debt, right? So a user can simply refuse to pay back their outstanding debts forever. And to solve this, Walrus places an interest rate on debt. So if your node got slashed on Epoch 2 and you don't repay on Epoch 3, your debt increases, so on forever. As an extra incentive, even if you don't repay forever and essentially you owe zero, Walrus will always allow you to redeem a base amount, let's say 10%, regardless of how much debt you owe. This is to incentivize to really close the positions and pay back the system. As you guys may have noticed, this works really well for Walrus from a developer perspective and security perspective, but it is hell for end users, right? End users want things to be fast and done. They don't want to have to understand stage 1, stage 2, voting, any of that. They don't want to wait 2 weeks. They simply want in and out. Whenever the token dumps, they want to stake and sell, and so on. And this is where liquid staking tokens really shine, right? Because they abstract the whole process. Now users can participate in the consensus of Walrus by simply buying the coin, by simply holding on their wallet, and whenever they want to stake, they can simply swap it, right? They don't really have to interact with the consensus directly. They can leave that for people who have more knowledge on it. They're interest-bearing, so you are automatically earning the rewards. You don't have to worry about that. And those are not self-custodial. Your NFT objects are actually held on a shared object, so they actually enhance the security of Walrus because if there is any slashing, the LSTs can cancel the debts for you. You will not be able to just hold your wall coins from the system. So what is Winter Walrus? It is a framework to issue liquid staking tokens on Walrus. This means that you don't need to know how to code. You don't have to have any technical knowledge. With a few lines of code and by contacting us, you can make your own liquid staking coin. This brings a lot of benefits because the code is already audited and open source. This means that you don't need to re-audit, right? If I'm a DeFi protocol that doesn't want to really understand how Walrus works, but you want to issue your own LST, maybe for your vaults to yield aggregator, you can simply issue your own and you know that it's secure and safe. You also inherit all DeFi composability. Because if you have Bucket or Scallop that integrates with one LST, it automatically supports all the other ones that the framework can issue. And it also provides instant liquidity. We will dive into this topic on the following slides. This is an image of how the whole process works. You can see on one side you have the LST owners or issuers. They can range from a dApp, like Double Up, we have the Upwall. They can be a community, such as the Turkey community, or even a KOL, like Brad Smith. He has the Bread Wall. Winter Walrus, the standard, sits in the middle. It controls the shared objects. But all the rights, the admin capability sits with the LST issuer. They can set up the fees, staking, unstaking, and transmutation fees, and they can decide which nodes the coins will stake from and withdraw from. On this slide, we'll dive deeper on how the protocol addresses the liquidity issues of LSTs. Because imagine, we are a framework. Imagine if we have 1,000 LSTs issued. We are not going to have 1,000 pools with enough liquidity for users to swap in and swap out. And that's the whole benefit of the LST, right? To abstract the staking and unstaking process of Walrus. So what we do is that the framework controls every shared object, so it knows the exchange rate between all of them. So what it does is that if I have Breadwall and I want to swap it to Sui, first the protocol will see what is the exchange rate between Breadwall and Winter Walrus. That's a first-class citizen LST issued by us. It will burn Breadwall, it will mint Winterwall, and then it will swap on any decentralized exchange using an aggregator to the coin the user wishes to receive. You can essentially think as a zero slippage swap. Because we control both LSTs, we can mint and burn one another at the right amount. Where can you use those tokens today? You can use them on Nemo. That's a yield strategy protocol. So for example, if you're bullish on Walrus, if you believe that Walrus will be storing more data in the futures, yet this means that the yield will increase, you can buy yield today, right? And once Walrus gets more data stored in it, you can sell it at a profit. You can also just provide liquidity on the many decentralized exchanges, Cetus, for example. You can participate into our point system that is coming up pretty soon. That's the alpha for today. And we also are integrated with Bucket, so you can mint some stablecoin to enhance your portfolio yields. This will be all for me today. Thank you, guys. I hope you understand what. For sure.